Quantum gravity at small scales. Hello and welcome. Today we are going on a journey to the absolute edge of what is known, to the deepest and most profound frontier of reality itself. We're not traveling to a distant galaxy, but inward, downward, into the very fabric of the cosmos. We are going to explore the enigma of quantum gravity at the smallest scales imaginable. To begin, let's consider two pillars of modern physics. On one hand, we have Einstein's general relativity. This is the physics of the very large, the grand, graceful dance of galaxies, the swirling ballet of black holes, the gentle curve of spacetime that guides the planets in their orbits. It's a theory of breathtaking beauty, portraying a universe that is smooth, continuous, and geometric. It's the cosmos as a vast cosmic canvas. On the other hand, we have quantum mechanics. This is the physics of the very small, the frantic, chaotic, and probabilistic world of atoms and subatomic particles. Here, reality is not smooth, but grainy. Particles can be in two places at once. They pop in and out of existence, and they communicate instantaneously through spooky connections. It's a world of potential, of ghostly waves of possibility, and of fundamental uncertainty. And for nearly a century, these two theories have been at war, a silent, cold war for the soul of reality itself. You see, both theories are spectacularly successful in their own domains, but when their worlds collide, when we try to apply the rules of the quantum to the realm of gravity and the extremely small, our understanding of the universe simply shatters. The equations break down. They produce nonsensical answers, infinities, and paradoxes. It's as if the universe has two sets of rules that are utterly incompatible, but the universe is one. It is a single, unified entity. So, there must be a deeper truth, a more fundamental language that can unite these two warring kingdoms. This sought-after theory, this holy grail of physics, is what we call quantum gravity. And to find it, we must venture into realms so tiny they defy not just our instruments, but our very imagination. So, let's shrink down, smaller than an atom, smaller than a proton. We are going to the Planck scale. Now, I won't give you a number, because it's a number so small, it has no meaning in our everyday lives. But imagine this. If an atom were the size of our entire observable universe, then the Planck scale would be roughly the size of a single tree on a planet orbiting a star in that universe. It is the ultimate basement level of reality. And at this scale, the cosmos does not look like anything we know. The smooth cosmic canvas of Einstein's universe, it vanishes. In its place, we find what physicists call quantum foam. I love this term. It's not a rigid, fixed structure. It's a seething, bubbling, turbulent ocean of pure potential. Imagine space-time not as a still pond, but as a pot of water at a furious, rolling boil. Tiny bubbles of space-time itself are constantly forming and popping in and out of existence. These are not bubbles in space, they are space and time. Here, the very concepts of here and there, before and after, lose their meaning. Causality itself stutters and flickers. In this foamy chaos, the universe is constantly giving birth to tiny, short-lived wormholes and miniature black holes that evaporate in an instant. It is a genesis and an aphesis, happening over and over, trillions upon trillions of times in the space of a single heartbeat. This is the primordial chaos from which the orderly universe we perceive is born. We live our lives riding the crest of this wave, completely unaware of the tempest raging beneath our feet. Now, how do we begin to describe such a place? One of the most compelling and truly magical ideas is the holographic principle. Close your eyes for a moment and picture a hologram. On a flat, two-dimensional piece of film, you can encode all the information needed to project a perfect three-dimensional image. Every detail, every depth, every shimmer of light is contained on that flat surface. The three-dimensionality is an illusion, a projection. The holographic principle suggests that our universe operates in a similar, but far more profound way. It proposes that all the information that makes up our seemingly three-dimensional reality, you, me, the stars, the galaxies, is actually encoded on a distant two-dimensional surface that surrounds us. We are, in a very real sense, living inside a cosmic projection, a hologram. Think about that. The solidity of the chair you're sitting on, the wind on your face, the vast emptiness of space. All of it might be a magnificent illusion generated from information stored on the boundary of the universe. This isn't just a wild guess. It emerges directly from the study of black holes and the nature of information, suggesting that the true, fundamental degrees of freedom of the universe are not the three-dimensional volumes we see, but a vast, interconnected network of information on a two-dimensional screen. This leads us to another breathtaking concept, the idea that space-time is emergent. We are taught to think of space and time as the fundamental stage upon which the drama of the universe plays out. But what if the stage itself is part of the play? What if space-time is not fundamental, but emerges from something deeper, something more primitive? Imagine a movie on a screen. The story seems continuous and smooth. But if you look closely, you see it's made of individual, static frames. 24 frames per second creates the illusion of fluid motion. The motion is not fundamental. It emerges from the rapid succession of still images. Now take that idea and apply it to the fabric of reality. What if the smooth continuity of space-time emerges from a vast number of tiny, discrete atoms of space and time? What if these fundamental building blocks are interconnected in a cosmic web, and their relationships, their entanglements, create the geometry of space-time that we feel? Gravity, then, would not be a fundamental force in the way we think of it. It wouldn't be a force that travels through space. Instead, it would be a side effect, a consequence, an echo of the underlying entangled structure of these fundamental atoms. It would be like the warmth of a crowd. The warmth isn't a fundamental entity. It emerges from the collective motion and energy of all the individuals. In this view, gravity is the thermodynamic warmth of the cosmos itself. This is where the magic becomes almost palpable. It suggests that the universe is fundamentally woven from information, not solid, hard little billiard balls, but bits, qubits, possibilities. The universe at its heart may be a cosmic quantum computer, and reality is the output of its ceaseless calculation. The laws of physics are its algorithms. The dance of particles and forces is the data processing. This is a view where consciousness and reality might be more deeply linked than we ever dared to believe. If the world is made of information, then what is the act of observation but a participation in the cosmic process of collapsing possibility into actuality? We are not just passive observers of a pre-recorded film. We are active participants in its rendering. Now let's take this to its most extreme and mind-bending environment, the heart of a black hole. A black hole is where the war between gravity and the quantum comes to a violent head. According to general relativity, at the very center of a black hole lies a singularity, a point of infinite density where the laws of physics simply cease to exist. It's a place where space-time is torn apart. The equations scream in protest, but quantum gravity tells us that this cannot be the final answer. Infinity is nature's way of telling us we're wrong. So what really happens there? One of the most beautiful ideas which ties back to the holographic principle, is that the singularity is not a point of destruction, but a transformation. Perhaps the intense gravity does not crush matter into oblivion, but instead, it compresses it to the point where it becomes information. This information is then encoded on the event horizon, the point of no return, like data being written to a cosmic hard drive. The black hole, in this view, is the ultimate hologram. All the information about what fell in is preserved on its shimmering, two-dimensional surface. And this leads to even more fantastic possibilities. Some theories suggest that the interior of a black hole might not be a crushing pit, but a gateway, a bridge to another universe, a new region of space-time that is born from the collapse. Our Big Bang, the event that created our entire cosmos, could have been the white hole eruption from a black hole in a parent universe. We could be living inside a cosmic matryoshka doll, a universe within a universe, all connected through these gravitational gateways. As we push our understanding, we start to see the practical and futuristic implications of mastering quantum gravity. The first and most profound would be the ability to manipulate space-time itself. If gravity is not a fundamental force, but an emergent property of an underlying structure, then in theory, we could learn to engineer that structure. This is the dream of gravitational technology. Imagine a spacecraft that doesn't need fuel. Instead, it manipulates the quantum foam beneath it, smoothing out space-time in front and bunching it up behind, effectively surfing the fabric of the cosmos. We could travel to the stars not by pushing through space, but by folding it. The universe would become an interconnected neighborhood. We could create stable wormholes, not as science fiction, but as engineering projects, creating shortcuts across the galaxy. We might even learn to stabilize the quantum fluctuations of the vacuum, tapping into the infinite energy of the zero-point field, the very hum of existence. But the implications go far beyond travel and energy. If the universe is a quantum computer, then understanding quantum gravity is like obtaining the source code. We could, in principle, learn to run new algorithms. We could manipulate the very laws of physics in localized regions. We could create materials with impossible properties, build structures that are stabilized by entangled space-time itself, and perhaps even communicate in ways that transcend our current understanding of light and time. This journey to the smallest scales is, paradoxically, a journey to the biggest picture. It's a quest that forces us to confront the very nature of reality, consciousness, and our place in the cosmos. Are we mere spectators, or are we, in some small but significant way, co-creators of this magnificent holographic illusion? The search for quantum gravity is more than a scientific endeavor. It is a philosophical and spiritual pilgrimage to the source. It is our species' attempt to read the cosmic script, to understand the grammar of existence. We are peeling back the layers of the real, and what we are finding is more strange, more beautiful, and more magical than any myth or legend ever conceived. The universe is not just stranger than we imagine. It is stranger than we can imagine. And we are just beginning to glimpse its deepest secrets. If this journey to the edge of reality captivated your imagination, if you felt that sense of wonder, then please do help this channel grow. Like this video, it truly helps the algorithm share these ideas with other curious minds. And subscribe to the channel so you don't miss our next dive into the cosmos. I would love to hear what you think. Which of these concepts, the quantum foam, the holographic universe, emergent space-time, resonates most deeply with you? Do you think reality is ultimately made of information? Let me know your thoughts in the comments below. This conversation is what makes this community so special. And if you hunger for more, if you want to explore these ideas further, to dive into the holographic multiverse and the idea that our cosmos is just one of countless projections in a vast cosmic network, then I invite you to check out my book, Holographic Multiverse. We've only scratched the surface today. The book is a deep dive into the implications of a reality built from information, exploring parallel worlds, cosmic consciousness, and the ultimate nature of existence. The link to purchase your copy is in the video description below. Thank you for watching, for wondering, and for being part of this incredible journey of discovery. Until next time, keep looking up and keep looking within.